I'm doing problem number 1. So I'm gonna find the 6 trigonomic functions of these coordinates. I wrote down all the trigonomic functions. I remember the first sine, cosine, and tangent using SOHCAHTOA. And I wrote down the relationship to find it. And this is based off if the hypotenuse is already assumed to be 1. But I could just check to see if it's 1 anyways. If you want to use Pythagorean's theorem, a plus b equals c squared. You plug in this is a and b, and you'll get 9 over 9, which is just 1. Here's the work for that. Here's just a visual of these coordinates if you're a visual person. This is assuming if the hypotenuse or radius is 1. You can use these 3 rows and 2 columns to write your trigonomic functions. So I'm gonna go ahead and write down that sine is, which is y, this on the coordinates, and cosine is x. Right now, I'm writing down the 3 rows and 2 columns that I wrote down, but I'm not writing the relationship. I'm just plugging in the x and the y, which is cosine and sine. Tangents. So here is sine and cosine already filled out. We know that from just the base coordinates. So we're just gonna go ahead and fill in this column because it's just convenient and eye pleasing. So you can do this in any order you wanted to. So the tangent function is y over x. So take the coordinates and put the y over the x. I'm gonna go ahead and solve that. So negative square root of 5 over 3 over 2 over 3 is what it will look like. I'm going to make this into a multiplication problem by flipping the denominator and the numerator. So negative square root of 5 over 3 times 3 over 2 equals 3 square root of 5 negative over 6. That's my answer. I'm going to simplify that to 1/2 1 square root of 5 over 2 and put that in my tangent function. Okay, for the next column, we're gonna do these two. The cosecant, since that's the reciprocal of sine, it's just flipping the numerator and the denominator, which would make it 1 over y, because this is a y function. So I'm gonna go ahead and just put a 1 over here and then solve that. So 1 over square root of 5 over 3 looks like this. I'm gonna make it a multiplication problem and solve it. So 1 over 1 times 3 over negative square root of 5. I'm gonna so it's right here. I'm gonna get rid of that. Would just make it itself, but then I'll get rid of the radical, because you can't have radicals in the denominator. So multiply this by square root of 5 over square root of 5, and you can do that because square root of 5 over square root of 5 is just 1. That makes 3 square root of 5 over negative 5. So it's just negative 3 square root of 5 over 5, because it cancels out the radical sign. You can't simplify that anymore, so I'm going to leave it 3 over 5 and then square root of 5. That's going to be the cosecant. 3 square root of 5 over 5, negative. Make sure it's negative. The secant is going to be 1 over x. Same process, just doing the x. 1 over 2 over 3. That's just make that multiplication. 1 over 1 times 3 over 2, which is just the flipping it, and that's just gonna give it itself. So really just flipping these equals 3 over 2. That's just, you don't need to simplify that anymore. This is the secant that I've been filling out. Right here. 3 over 2, and then finally cotangent. The last one is this, since this is y over x, numerator to the denominator is x over y. So x is 2 over 3 over square root of 5 over 3 negative. It will look like this. And then that just makes it, I'm gonna do the same process as all I'm doing, make it a multiplication problem. 3 over square root of 5 times 2 over 3. By flipping those, that makes 6 over square root of 5 times 3. Gonna get rid of the radical sign in this problem. Make that times radical 5 over radical 5 is radical 5, 6 over negative 3, because it's still negative. And then I simplify that, because 6 over 3 is 2. Square root of 5 negative. You would get that. I'm going to put that in for negative 2 over 5. And now I have both columns filled and rows filled out.